Hi there, welcome back to my channel. If you watched the previous video, this is a continuation of geometry mathematics IGCSE. This is mathematics 0580. We started solving some previous questions and we are continuing in this video. So if you didn't get the first two questions, you can kindly watch this video right here, or simply check the video before this one and you should be able to catch up. So in this video, we are starting with this question, and we are going to apply a few circle theorem to solve this question. First of all, you can see that this line is parallel to this line, and it was clearly given also in the instruction. We said the question said DA is parallel to CB. That is this line DA, and this is line CB. So being parallel, I'll tell you in a few minutes what that implies. But before we go on, we'll also see that the question also said CU is a tangent. This is a tangent to the circle. The very first law in this theorem that you need to apply is the tangent rule. The tangent rule. The circle theorem rules are about 8 to 9 of them, depending on how you are breaking it down. But the tangent rule states that if you have an angle here, like this, let's say you have a circle, and then you have a tangent to that circle. The tangent is a line that touches the circle at just one point. So if you have this tangent, and this is the center of a circle, if you have a triangle forming from the chord that also touches that same point, this is the tangent, the point where the tangent is touching the circle. If you have a chord emanating from that point, any triangle formed on that base like this, if you have a triangle formed on that base, on this chord like this, the angle the chord makes with the tangent here, like that, is exactly the same as the angle here. So if this place is theta, for instance, then here will also be theta. So if you look at this diagram, it is very obvious. This is the triangle. This is the tangent, first of all. And on this tangent, you have a chord, the chord DC. So this is the tangent, and it makes angle 38 with the tangent. So with that angle, we can immediately see the triangle, which is DAC. So if here is 38, automatically the value for x is also 38 degrees. So one of our problem is solved. Okay, so you have that to be 38. And now in that triangle, you know, when you have two triangles and you are given two sides, two angles rather, here is 60 degrees. And we just found here to be 38 degrees. That is not drawn to scale. We just need to find here, and we know that the sum of angles in a triangle is 180 degrees. We can simply do 180 minus the sum of these two angles, that is 60 plus 38, that is 98 degrees, is equal to this angle here. Okay, and that's going to be 82 degrees. So we are using known angle to find unknown angles. This is 82 degrees. Okay, 90, 120, 180. But we are looking for y here. So the other time I was saying we also have parallel lines. So what do we do with this information? In the previous video, we talked about parallel lines and alternate angles. When you have an angle here, by the principle of alternate angle, the same angle will be the same as here. So now that we have alternate angle, these are the parallel lines. So this is a transversal to the parallel line. So if here is 38 degrees, automatically here also will be 38 degrees. Okay. Alternate angles form Z, kind of, or let's say like this, the way it is in this diagram. So as long as this and this are parallel, this angle must be equal to this angle. So we have ascertained that that is 38 degrees. Now, how do we find y? Because we still don't have this angle. So there are other things we can do. We can walk backwards, like the way we got this 38 from this 38 given here. We could have also gotten this 82 from here by simply doing angle on a straight line. So we add up this and subtract from 180, because angles on a straight line sum up to 180. So we'll be able to get this angle here. But we already got that from sum of angles in a triangle. So we still need to find this angle. There is one other principle I need to quickly tell you, and that is this simple theorem here. So if you have a quadrilateral in a circle with all the points touching the circumference like this, the opposing angles here are said to be supplementary. So if this angle is A and this angle is B, then the sum of the two angles must give you 180 degrees. It's a pretty simple theorem. You just need to remember it. So if you have opposing angles like that, the sum must be equal to 180. Same thing here. If here is W and here is K, for instance, then W plus K must give you 180. So without wasting much time, let's look at the quadrilateral ABCD. You can clearly see that here is 60 degrees. And if here is 60 degrees, by this simple theorem we just ascertained, here must be 120 degrees. So if here is 120 degrees, we need to now come back to this triangle. Triangle ABC, this, and this. So we now have a triangle with two known angles and one unknown angle. And by this same principle we applied here, sum of angles in a triangle is 180. So it means that y is going to be 180 degrees minus 38 minus 120. That's simply 22 degrees. So it's as simple as that. The question actually asked us to find x and y, and we have just done that. So the value of y is 22 degrees, and the value of x that we got earlier was 38 degrees. Because it is an IGCSE question, you need to supply your answer in the space provided. So here is 38 degrees, and here is 22 degrees. So I would have loved to continue, but I would continue in another video. Kindly remember to watch the previous video to catch up on what we've been doing so far, and remember to watch the next video. Thank you so much for watching. Click the subscribe button if you are yet to subscribe, and remember to give this video a thumbs up. See you in the next video.